Here's the home page for the Canvas page for this class, Calc 3, Math 253 here at Skyline College with me, Professor Evan Leach. This is going to be your main interface, the main place to go for what's going on in the class. The main thing that you have to do, the next thing to do will be here at home or here in the modules. The modules is just the home page without your to-do list. Your to-do list will sometimes be a bit of a mess because it's going to list every single meeting that's coming up. So that's a lot. But if you switch to the modules, you get a little bit less noise. And we can start off in the Calculus 3 Visitor Information Center. So I recommend that you just read through this first section. It's got some policy stuff. It's got some stuff with dealing for how to deal with Canvas. And it's got your first few assignments. So before we go through that, the other place to go for information is announcements. So you can check out, when I make announcements to the class, I'll just type them up and put them up here on Canvas. So if there's anything, if you're wondering if there's anything new going on, you can check the announcement page. One place that you'll find some of your assignments is in the discussions. This is also where I'm going to be posting all of the links to the recordings of our meetings. So clearly I forgot to put the shell for our first week's meetings, but the discussion section is where you'll find week 1 notes and videos. Zoom is where you'll find links to our meetings. Grades just takes you to your gradebook, your section of the gradebook. So this will give you an idea of what you have and haven't done. Right now you can see there are 3 active assignments. We're 12, 6, and 10 points, and I have not done them yet. I also recommend that you jump into the course syllabus and check out all the things that we will be doing. One thing to note in the course syllabus is that we have a textbook that is included when you registered for the class. So you don't have to go to the bookstore and buy a physical copy of the book. It's access to the class is included when you registered. So it's just called Calculus because all calculus books have the very boring title of just Calculus. And it is we're in the 7th edition, and it's the Hughes Hallett calculus books. For those of you in the know, that's how we always refer to calculus books. We're using the Hughes Hallett book. So if you ask another calculus professor, what textbook are you using? They'll just say calculus. And everybody will be like, oh, yes, yes, of course. Which is why if I ever write a calculus book, I'm going to call it something other than calculus, like Adventures in Math. Or something completely unrelated to math. Give it like a Dungeons and Dragons title or something. Professor Leach's Guide to Everything. I recommend that you have a calculator. The text instruments TI-84 is kind of the industry standard. They worked very hard for that market position, so we should fall right into that trap. It's not, as a graphing calculator, it's not a very good graphing calculator, but it is very good for a lot of other things. There's some important dates. Oh, clearly I have not, I'm glad I'm recording this because clearly I have not updated the dates because they're all in 2020. So apparently we're stuck in 2020. The rest of the syllabus is just explaining how things work in a math class. There's homework, there's quizzes, there's tests and a final exam, and there's attendance, which has been altered. There's a grading policy, and then there's a bunch of stuff related to Skyline. And then at the bottom, it's all the meetings that we have so far. eTextbook is if you want to open up the textbook and read it. I know this is a math class, and when you have a reading assignment for your homework, you just assume that there's no homework. But if you click on the eTextbook, eventually wileyplus is struggling. Eventually, it will just bring you to a copy of the book. And it shows up in this window and it's hard to read. And I think you can maximize it. But it is easier to click around and look for sections. So. All right, so there's your copy of the textbook. There's a lot. One of the things that's important to note about the textbook is that this is just like a regular old textbook. And if you scroll down to the end of a section, there will be a whole section of problems. So a lot of times when we're working on things, you'll say, can you write us a copy of the test that we can take before the test so that we know what the test is coming? Because you don't just want to take the test cold. So usually I'll just point you to the end of the section and you'll see there's exercises. You want some practice in problems 1 through 49, find the derivative. So that's a good way to grind out some problems and practice. So this is where you get your training montage. So put on some Rocky music and start doing some problems. In the files section is where you'll unsurprisingly find files. One of the things I'm gonna have, there'll be a folder where all the notes will be, the scanned notes from the class will show up. You can also check out my notes from 2020 in the fall. There's a lot of stuff in here. This includes the videos that were being stored in the file section before I had to upload to YouTube because I ran out of space. So here's where you can check out the notes from last year. And eventually things open up. Right. So the main place to go when you're wondering what to do in calculus, when you get to the end of your day and you think you're at the end of your day and think, you know what, I have not thought about calculus lately. Just jump onto Canvas and take a look at the modules and see if anything has showed up. Now, your first couple of assignments are in the Information Center, including a session 0 discussion where you just have to write a quick introduction. What do you care? What are you studying? What are you worried about? What are you looking forward to? And one of the important things is this question here where I say, what kind of problems are you interested in solving upon completing your educational goals? So I don't know if people still ask kids what you want to be when you grow up. I really don't like phrasing educational goals in terms of some job that you want to have in the future. I think that's a really archaic way to look at things. And it plays right into the mindset where your only value is the work that you can provide for some wealthy person to increase their wealth. I really don't like that mindset. So I really prefer to think about it as, what problems do you want to work on solving in the future? And think of problem solving as the goal of your education rather than getting a job as the goal of your education. So that's just philosophically, maybe there's no difference for you. Maybe you do want to sit at a computer and write code for 140 hours per week. If that's your goal, then that's fine. No judgment here. So you cruise down, you make your introduction, and then I go through and I give you 10 points. Also in this, oops, not in this one, in the modules. Also, there are some assignments where you are learning to work with wileyplus. Lots of dramatic pauses as things load. Is it still loading? Oh, there it is. There we go. So you just click on the questions. And some of these are multiple choice, and then sometimes you'll be having to type something in. Any questions? Great. All right. In case you're wondering why the big pause, all of a sudden it looks different. wileyplus is making things look different. I'm wondering, they probably did tell me that they were going to update the way things look. There was that whole, hey, we got a new look. Do you want to look around? I'm like, oh, no. And then I try to open an assignment. It's like, oh, and then I think, why does this all look different? So, all right, let's stop sharing. How's everybody okay?
Yes.
Great. Let's switch over to the board. Talked about me. Let's see, so you know who I am. We did the tour of Canvas. We had questions. So let's talk about what's new for Calculus 3. Let's talk about what Calculus 3 is all about. And then tomorrow we'll like really start doing calculus and stuff. So here's the good news for Calculus 3. Conceptually, we've got everything that we need. That's the good part. In Calculus 3, we're just taking what we learned in Calculus 1 and Calculus 2 and doing it for functions of more than one variable. So Calculus 3 is just single variable calculus for functions of more than one variable. So the thinking is the same. We just need to adapt our single variable calculus thinking to multivariable functions. So we're going to think of this less as doing new stuff, and we just need to update our single variable calculus thinking to functions of more than one variable. Well, not always functions. So we just need to take the same kind of thinking that we had in Calc 1 and Calc 2 and apply it to more than one variable. So let's remind ourselves, what were the things that we did in Calc 1 and Calc 2? There's a lot of machinery going on when we were learning calculus. but we can boil it down. It's often boiled down to two questions. I actually like to boil it down to one question, where we think of calculus as the study of infinity and all that goes along with infinity. What does it mean when we switch from the discrete to the continuous? But for differential calculus, the standard two big questions of calculus are to look at a function. I have to remember in calculus to switch back to x and y. I just finished a linear algebra class and everything was x1, x2, and x3. And let's say we have some function. Now a function of one variable is just going to produce a one-dimensional curve in two-dimensional space. So we have this function y equals f of x. We even restrict ourselves more by requiring one of the variables to be a function of the other variable for our basic questions. And the big question in differential calculus is, at a particular point on this curve, what is the slope of the tangent line? So at a point, let's say x equals c, what is the slope of the tangent line? And we learn that the slope is the derivative evaluated at c. And then we think about what that means in the context of a function. And we think of this as the instantaneous rate of change of the function at c. It's just a speedometer reading of the function at that moment. It's how y is changing with respect to x. Oops, I didn't need to scroll yet. So in integral calculus, in Calc 2, the big question that we were asking was, what is the area under the curve between two values? So we had some function. Oops. And now we're going to look at the area under the curve and above an interval. So that was the big question here. Area under the curve and above the interval from A to B. And we had notation for this because it's a math and we have notation for everything. So graphically, we're looking at the area under the curve f of x and above the interval from A to B. And then we have a way to interpret this. This means something. So the definite integral of a rate of change of a function from A to B gives us the change in the function from A to B. So the definite integral of a rate of change of a function, so look at the derivative, we integrate the rate of change, we find out how much the function has changed. And our favorite example, it's like in every calculus book, if this is velocity, then the integral will give us change in position, since velocity is the rate of change of position. So what we want to point out to move this into multivariable calculus is we have to look at what's going to be changing. Rather than a function of one variable, we're going to have to think about what a function of two variables looks like. So we're going to have to spend some time learning to describe the functions geometrically and then interpret their what they represent. So we're going to have to change our function of one variable to a function of two variables. Think about the results of that in graphically, and then see how we have to alter our description of what's going on. So now what we need to do is upgrade our function of one variable to a function of two variables. So we're going to start with, what does it mean when we have some, say, function of a single variable, and then switch to a function of two variables? And we start with functions. Once we get used to dealing with functions, where one variable is a function of the others, we can just switch to more generic relations between them with equations. So in a function of one variable, we have an x and a y, and we know what the graph should look like. The graph is a one-dimensional curve in two-dimensional space. So the graph is a one-dimensional curve in two-dimensional space. So the graph is a one-dimensional curve in two-dimensional space. At each point x, the value of y, we evaluate the function, and we make that the height above the x-axis. So we end up with a one-dimensional curve in two-dimensional space. It's just the height above the x-axis. So now let's think about, do the same thing when we have a function of two variables. Now for an input, we're taking an x and a y. So rather than having a set of inputs that's just the x-axis, we're going to have a set of inputs that's an x and a y-axis. So the graph, we're still going to have, in this case, z is the height above the xy plane. So above each point in the xy plane, we're going to plot a z value. So z will be the height above the xy plane. So instead of getting a one-dimensional curve in two-dimensional space, we'll have a two-dimensional surface in three-dimensional space. So in this case, the graph is a two-dimensional curve, or sorry, a two-dimensional surface in three-dimensional space. Three dimensions because we have an x, a y, and a z. That's what each point is going to have an x, a y, and a z. Just like in a function of one variable, we had an x and a y, so we'll have two-dimensional space. So when we have a function of two variables, we're going to think about a two-dimensional surface in three-dimensional space. And then we're going to ask the same questions that we asked before. What is the differential calculus question going to be? And what's the integral calculus question going to be? So we're going to have, what is the slope? When we upgrade from a curve to a surface, what's going to happen to our tangent line? What does that become? How will we calculate it? How will we describe it? And then we think about the integral calculus question. When we're looking at the area under a curve and above an interval, what happens when we upgrade our function to a function of two variables? So instead of an area, what are we going to be calculating? And we can't have a surface, look under a surface and above an interval. We'll have to look at under a surface and above an area. We have a bunch of x, y's that we're trying to plug into the function. So that's the first stage. We have to learn how to describe our two-dimensional surfaces in three-dimensional space. Once we do that, then we can update our calculus concepts to fit those descriptions. Any questions?
Will we be sticking to just a maximum of 3 variables, or will we be going beyond that at some point?
I'm sorry, say that again.
Will we be sticking to two-dimensional in three-dimensional space, or will we eventually go beyond that point and add more variables down the line?
We will definitely go beyond that. So I like to think about multivariable calculus. The reason we have a separate class for this is it's kind of like owning a bunch of dogs. Like going from 0 dogs to 1 dog is a very big change in how you run your life. It makes a big change in the household dynamic. Going from 1 dog to 2 dogs is another big change in the household dynamic and how you have to react to things. But once you're used to 2 dogs, getting a 3rd dog doesn't really change all that much. It's really kind of like go from 0 to 1, big deal. From 1 to 2, big deal. After 2, you got this. And calculus kind of works the same way. Started learning to describe doing calculus with just 1 variable, that's a lot of work. Going from 1 variable to 2 variables, also a lot of work. But once you've got that, going from a function of 2 variables to a function of 3 variables is not much of a big deal. It actually even gets better because 2 variable functions, we're in 3-dimensional space. If I have a function of 3 variables, I'm now in 4-dimensional space. I'm not even going to bother trying to picture what's going on because I don't have a picture of 4-dimensional space. So I've heard that the same is also true of having children. Having your first child, big change. Having a second child, major change because now you got extra humans. But the 3rd kid, by the time you got this down, you got the process down. Any questions? I do a lot of comparing children to dogs. I recognize that dogs are easier, but I mean the analogy is just it's just too easy to make. You get the behavior that you reinforce, all the stuff. Any other questions? Comments? A good question. How often are we going to use matrices? We are not going to use matrices very often. This class does not operate under the assumption that everybody has had a first course in linear algebra. So matrices won't come up as often. When matrices do come up, then we can just deal with it in pieces. But I don't make any assumption that y'all have had a first course in linear algebra. Any other questions? How's everybody okay? So this is the fun part of Calc 3. That's right, I said fun. Always when we're looking at concepts in Calc 3, we want to be thinking about where this concept comes from in Calc 2 and Calc 1. So the thinking is going to be the same. We still want to think about the instantaneous rate of change. We have to make sure that we can think about that in all the different ways. So we know we're supposed to say instantaneous rate of change of the function when x equals c. We should also recognize that we write that as dy dx. So that's the rate of change of y with respect to x at that one point. So it's the rate of change of y with respect to x, which means we're going to have to think about describing things like direction. We know that when we find the equation of a tangent line, that the slope represents a direction. But once we go from x and y, we no longer get to use just one number to describe a direction. A line is very simple. It just has one direction. And that's why we can get away with rise over run, dy over dx. We get away with it because there's only two. There's x, there's y. If there's x, a y, and a z, then we have to have a more sophisticated view of how direction works. So vectors are going to show up in this class. So if you've been in physics, you've dealt with vectors. If you've been in linear algebra, you've dealt with vectors. Welcome to Calc 3. Vectors are showing up again. So it's always vectors. Because we've got to learn how to describe direction. Best way to do that for Calc 3 is to think about how we describe direction in Calc 2 or Calc 1 and Calc 2, and then adapt it to Calc 3. Any questions? In a sense, math looks forward always by looking backwards, which is the third of the great tricks of mathematics. The three great tricks of mathematics are to add 0, multiply by 1, or reduce your problem to a previous problem and adapt it. That's all. Just go back to a previous problem and see how you could use that in the new problem. Any questions? Comments? Snide remarks? All right, that's enough rambly stuff for today. Tomorrow, what we're going to do is we're going to take a look at derivatives and what they mean, and then we'll start doing the first major thing that we have to do, describing functions of two variables. So for those of you who like to read along in the book, that's going to be in chapter 12, functions of two variables. For those of you who don't like reading along in the book, it's still in chapter 12. You should go and try to read the math book. The location of the subject in the book is not dependent upon whether you like to read or not like to read. All right, so let's stop the recording and cover any technical questions that we need to talk about.